All right, well, welcome back. I hope you enjoyed those breakouts, if you could get into them. And thank you to Automation Alley for the refreshment break. Also, silence your cell phones if you would. We've got a couple of really exciting things offering this afternoon, and we're going to talk a little bit about what they are in a second. But I wanted to introduce you to two people before we go any further. Simone Ross, where's Simone? Stand up, Simone. She doesn't like to stand up, but Simone put the whole program together, had the idea to bring Techonomy to Detroit in the first place, and has been extraordinarily committed to making it happen all along. So none of you would be here if it wasn't for her. All right. And Josh Campbell, where's Josh? Josh, if you've wondered why this thing is looking good, Josh is the one that does our partnerships, works with a lot of the businesses that are our partners, and he's been exceptional at getting the business community excited about what we're doing, and he's key to making Techonomy work. So thank you to Josh. So this afternoon we're going to look at making things in a lot of different ways, and how to stimulate entrepreneurship even more in Detroit and globally. And we're going to close with Jack Dorsey at the end of the day and some local entrepreneurs. So I want to start off the afternoon with my friend Zachary Karabell, who is an investor and a writer. He writes a regular column for Reuters, and he's done all kinds of things. You'll see he's extremely erudite. He's going to be interviewing one of my favorite technologists, Rodney Brooks, who's chairman and CTO of Rethink Robotics. As you'll learn, they're doing extraordinary things that are really changing the nature of work. So Zachary and Rodney, please join us.
So in 23 minutes or less, we're going to try to have a discussion about Joseph Schumpeter, creative destruction, whether or not technology is a disruptive force that we then have to clean up after, or a creative force that can help build the world that we want to live in and the communities of our future. And there's no one who's been more kind of at the epicenter of applied technologies in the form of robotics, which is, as we know, been at the heart of the transformation of industrial systems everywhere for the past 30 years plus. Than Rodney has been. And I think we're going to start with something we were talking about before, which was the degree to which there's a lot of emphasis on education and skills. You know, we read lots of stories about industrial America now becoming a high-tech job that actually can't find sufficient people with sufficient skills. But I believe you have a somewhat different take on it than that kind of common narrative, which is we're not training our workforce for the industrial and factory work of tomorrow, and that we need to first focus on that before we then create this vibrant new industrial system.
Yeah, so I want to start, who has something like this? Yeah, did any of you take a course at a community college on how to use this Unix-based machine? No. It was designed so that you could learn how to use it yourself. It was designed on some precedents that were common in the culture, but it was designed on the idea that you would learn how to use it yourself. I think in manufacturing, we have suffered from it being an engineering domain, and manufacturing engineers like to know how complicated their machines are. And so they become more and more difficult to use. It's about complexity, and the complexity is exposed. But what if instead we went like we did with consumer products and hide the complexity and instead make them easy to use, so that factory floor workers can use the most complex machines that there are and be productive with them. So we bring people along on the job to be able to be more productive by providing them the right tools.
Although you could, I mean, to push back on that, you could say that presented with that device, right, a smartphone, which has as much computing power as a large Unix system had in the 1970s.
Way more.
Does require certain skills of manipulating data or being able to search for meaningful information that you can't just acquire by handing someone.
No, I said it's in the cultural, based on the culture. So an example, an early company of mine was iRobot. We made I'm not part of that company anymore, but we made the Roomba and military robots, which are used in Afghanistan and Iraq for roadside bombs. So initially, when we sent those robots over there, we had complex menu systems. Then when we got feedback from 19-year-old kids out there with bullets flying past their heads saying, this isn't really useful to us, we put a Game Boy controller on it, and with 5 minutes play, they had 80% of the capability of the robot, and they never got to that with 2 months training before. So find the right cultural reference. Now, people are generally used to, for instance, touchscreens. They're generally used to actually pretty sucky DVD interfaces.
Right.
So if you build on that, you can get some pretty useful tools pretty straightforwardly.
Now, there's also another common narrative, and I'm probably guilty of this common narrative about the way in which the changes in industrial America have been a real challenge to labor forces, and particularly to places like Detroit. Separate from global trade, the very fact that if you open a factory today, because of the robotics that you've been so central in creating, those robotics mean that you can have 500 people having far more output, far more efficiently, with just-in-time manufacturing and flexible floors than 5,000 people would have been able to do on fixed-line manufacturing 30 years ago. And so the rub has been, is technology, the way there's Andrew McAfee and Eric Brynjolfsson, two of your former MIT colleagues, professors at MIT, talked about the way in which technology is actually a middle-class job destroyer, not a middle-class job creator. But you have a different perspective, I think, on the role that robotics and automation can play in industrial societies and the way in which that links to jobs.
Conventional automation has been, I liken it to the old mainframe computers, which most of you are too young to have known about. But back when I was a boy, computers were behind a glass wall. Ordinary people didn't touch them. And then came the PC, and then ordinary people started interacting with PCs, and then came a tremendous flowering. So think about it that other way around. Can I show some slides here? I'll just show you what I've been doing. Do I need to press a button, or are they just going to come up? Yeah, so this is Baxter, a robot that my company Rethink Robotics has been building. We started shipping it in January. It's a production assistant robot. The key thing about it, though, is that it's, I'm not clicking. Oh, there it goes, yeah. The key thing about it, though, is that it's safe for ordinary people to touch. That's a worker in the factory, in that particular factory. But the workers can program the robot and learn to program the robot in minutes. So we've had cases where we've shipped a robot to a factory worker who's worked on the line for 25 years has learned to program the robot within an hour of it arriving and got it to do a useful task. And they do it by grabbing the robot's arms, by using the buttons on the forearms to select menu items that come up on the screen. We actually don't use touch screens because in factories a lot of people wear gloves and touch screens don't work real well. But then ordinary people are programming the robots, and then they're safe to interact with. This is an example from a plastics factory, and you'll see a couple of Baxters here with people in close with them, sharing the task, doing some of the dull, repetitive tasks. Interesting thing here, as we zoom in on the hands of these robots, the hands were all made locally within the factories. Sometimes in the really small factories, they go out and use Tech Shop to do 3D printing of the fingers. So the next panel is going to be about the maker movement. So this is a robot doing kitting. And what we've been finding in a lot of the factories is the workers come up and ask, can we get the robot to do this particular task? Because we really don't like doing this task. It's really boring. Can they do it for us?
And the smiley face, that's the screen, that's to make people feel like we come in peace?
No, actually it's very important. It's not about smiling. There's no smile there. But the robot glances where it's about to move. So it's telegraphing what it's going to do. So immediately, if you're around it, you're never surprised by its motion, because just as you glance where you're about to reach out, it glances, and so it's telegraphing its intent. It's aware of people, and it will slow down. And if they do get in its way, it stops. So it's being aware of people, and it's signaling them what it's going to do.
If we come back in 10 years to Techonomy 2023 in Detroit, will I be engaged in a conversation with Baxter about its views of?
No, Baxter is never going to be truly smart. It's pretty dumb. It's got a little bit of common sense. It knows it's not a trajectory controlled robot like all the robots are in Detroit. Instead of following trajectories, it's doing tasks. So if it's moving this and it drops it, it doesn't keep moving it with an empty hand. It goes back to pick it up because it sort of has an understanding of that task level of what it's doing. But it's not truly intelligent. And
so in what way, though, will that facilitate a revitalization, not just of manufacturing in terms of output? Because it's very clear the way in which automation, robotics, software, all these systems allow for much greater productivity. It's still less clear how it leads to greater opportunity of employment and activity, particularly in an urban or any area. So how does this then translate? I mean, we talked a little bit about small factories would have been the norm prior to the late 19th century because it was just easier to organize a factory of 50 people. We didn't really know how to do huge factories. But that was a real source of economic vitality. Can you see these being a way to create smaller manufacturing hubs, literally?
Yeah, I see that what we've got into is a very top-down command and control sort of architecture. But information technology, as it comes to manufacturing, and many components allow new sorts of business models. Does anyone here, I use this all the time, does anyone here use MFG.com, website MFG.com? Anyone heard of it? Okay, well, I looked today. There was about $73 million of business being advertised there. It's very small facilities, some just 2 people, some 10 people, who build small runs of parts. If you want prototype parts or a small run of parts, you go on the website, you put up your CAD drawings, they bid on it, you select who you're going to have, who you're going to do the work, and 48 hours later, they arrive at your place. Now, why does this work? It works because of standard CAD drawings, PDF, web, credit card payment services on the web, and FedEx. When you put all those things together, little tiny companies that used to have an addressable market of about 3 miles now have a national market. And it's really changed the dynamics for rapid prototyping and small batch manufacturing. So the new tools put together imply new business models. And I think we often forget about how radically the PC and the progeny of the PC completely changed business models. I know later today the CEO of Twitter is going to be here. One of my friends a few years ago, Deb Roy, started a company called Bluefin Analytics, Bluefin Labs, which does Twitter analytics, and then he got bought by Twitter. Who knew you needed a Twitter analytics company 5 years ago? That question wouldn't have made sense. Likewise, I think we're going to see lots of new business models. If I could just show, I don't think this, if we can go back to the slides, I don't think this particular one is going to happen, but it's an example of what could happen. So, I see, everything's a little slower than I'd hoped. So here's what happens now. This is the big model that we talk about. A product company designs some product, and then they ship that design to a big factory, which happens to have a Chinese flag on it. That factory has thousands of people doing really mind-dulling jobs. It makes lots of product. The product gets sent to retail, either big box retail or now virtual retail, and that gets shipped out to consumers across the country. As we get more intelligent CAD, which includes manufacturing instructions, and have manufacturing lines that are quick to set up, not the current manufacturing lines with current robots take a year or 18 months to set up. Here's an example of how that model might change. The product companies might develop the product design and sell the product design directly to the retail. So maybe the retailer is say Walmart. Then Walmart says, okay, I need 50,000 of these units in Seattle. I need 100,000 in Kansas. And then little companies, little agile manufacturers bid on those, build them locally, don't have to ship them all over the place. And so the supply chain becomes much, much shorter and much more able to be responsive to need.
And will
That's
this-
an example
Will
of
this
what
be a
could
product
happen.
of a robotic, advanced robotics, the way that you're developing with your company, or will it also be a product of 3D printing?
I think it's all of that. It's 3D printing. It's better CAD. Then there'll be also and new sorts of robots where you don't have to have a tremendously concentrated, sophisticated capability in everything. You can put the stuff together yourself, as we've been able to do with PCs in offices for years. Graphics people used Apple computers for years and years because they were easy to use, and that's really what kept Apple alive during the dark years.
And we'll be able to get better graphics, because right now this looks a little bit like carrots and castles will be proliferating throughout the country.
It's folksy.
No, it is. It's true. But there'll be a next generation of that as well. So in this model, will you have factories that are...
And I don't know that that's going to be the particular model. I'm just saying, for example.
But you'll have small, flexible... Will each of these be able to produce multiple types of products?
Yeah, they'll be bidding on stuff all the time, and you know, one of the glamorous things about international travel in the old days was you go different places and you could buy different stuff. Now every store in every airport is the same.
Right.
This sort of will, I think, enable things to be more culturally local and for people to be proud of what they're doing.
So it's sort of it's both a onshoring and a relocalization of manufacturing.
I see both as possible, and it's not just robotics, it's not just 3D printing, it's not just new tools on the web, it's all of those things combined, and stuff that we can't even imagine just yet.
So what are the obstacles to this? I mean, what prevents this? Is it purely a technology issue right now?
No, I think people are working on the technologies. 3D printing is just going wild. Tech shops have become places where entrepreneurs go and develop their product, and then they use MFG.com. So I think we're starting to see this really have an impact. And then we're starting to see some big players. I don't know if people noticed last week, Motorola said they're going to start building a smartphone, and they're going to build it in Texas. They're not going to build it in Asia. That's a big step, I think. By the way, we build our robot in the U.S., totally made in the U.S.
And how do you build your robot?
We have almost 20 primary suppliers around the country who build components, and then they go to about 4 different assemblers who put together sub-assemblies, and then they go to a final assembly place. So it's shipped all around the country. But the reason we do that is because we're using particular technologies where there's localized capability. So for instance, the gears in our gearboxes are powdered metal gears. So making things out of powdered metal where you compress something in a mold and then sinter it, it's much, much cheaper than steel gears, but you need a lot better computation to model what's happening. But that technology came out of Penn State. So all the powdered metal companies that can do this are in central Pennsylvania. So we go to central Pennsylvania to make our gears rather than make them somewhere where the expertise is not localized.
And the other thing about this model, so would this model then work in the way in which you had, in industrial development in the 19th century, you had factories which were actually embedded in the urban area, right? The development in the 20th century was for large factories to go outside of the area because they were too large and demanded too much resources and pollutants for them to easily be located in a downtown. Could you see this being something where you would start to have, relatively small manufacturing floors that could be placed within urban environments?
Yeah, I think that's a strong likelihood. Most of the companies that contract on MFG.com are very small and in urban environments. The neighborhood machine shop that you still see.
Where do you do your production? I'm just curious. Of the actual robots, the physical.
The final assembly?
Yeah.
It's about an hour out of Boston.
Okay.
Yeah.
And then you.
But the rest, it's Minnesota, it's Washington State, it's Michigan, it's Chicago, Illinois, it's Pennsylvania, it's all over the country. Different sub pieces are built.
So your view would be that the more these things become embedded in the next generation of manufacturing, that creates an efflorescence of its own, not one that you can easily chart, right? You can't know the exact outcome of these, but that it creates its own sort of next generation of multifaceted creative manufacturing.
Yeah,
services.
and all sorts of services and new business models. If this clicks right, I'm going to show just some examples. You know, we've had plug-and-play equipment in IT for a long time. We haven't had plug-and-play equipment in manufacturing. In analogy to the Twitter analytics company, I think there'll be lots and lots of little companies doing supply chain optimization. And then there'll be some sort of radical changes. I call this one delivery flow because I don't know what it means, but here's the analogy. A few years ago, GE aircraft engines stopped selling engines and started selling hours of engine service on airplanes. So our whole supply chain model for manufacturing is still about the physical stuff going, and I think there's meta levels that information technology combined with this super CAD will lead to, the sort of the, not by direct analogy, but the Amazons of supply chain. And it's going to be very different from what it is now. I wish I was as smart as Jeff Bezos so I could figure out how to make this happen. But
well, perhaps you should buy the Detroit Free Press, and then you could be kind of like a mini version of Jeff Bezos. I think we have time for a question or two. If there's anyone around the mics, I can't see. If not, we can. Anyone? No? This is just too fascinating at the end of a long afternoon. Okay, we will, and then we will segue into our next, sir.
Thanks for being here. Andrew Humphrey, WDIV in Detroit. With regard to, well, actually, two questions, and I promise to be brief. In robotics, what has been the reaction so far from developing governments? Because in the 60 Minutes piece on Baxter and your company, it was said it might be direct competition with the low-wage jobs that are in the developing world. So what's the initial reaction there? And the second question regarding automation, how do you still maintain accountability when it comes to automation, especially when you're talking about automated warfare and workplace accidents?
Okay, first question. The reason I started the company was I was doing a lot of manufacturing in China and saw that the end of that low-cost labor was coming. As year after year, we found it harder and harder to get more workers to come, more shifts coming on, and we see that dynamic playing out at Foxconn now. Thankfully, wages have gone up in China. People aren't as desperate for the jobs. They're doing other things. And so now they're pushing back on their working conditions, and that will continue to happen. You go down to Vietnam, which is where a lot of stuff is happening now, but then where do you go after that? Already Thailand last year was the 5th largest market for industrial robots because it's already become industrialized. So I see that low-cost labor is finally disappearing, and it's just not going to be there anymore. For accountability, that's a real issue. On the military side, I was involved in military robots at iRobot, but they were bomb disposal robots. They were not weaponized in any sense. But I will point out one thing that some people miss is that a robot can afford to shoot second. A 19-year-old kid that we put in uniform and send into some place, they're going to be very worried, and they're going to shoot first. And in many circumstances, a robot can sit there and take it. And doesn't have to shoot back. So some people worry that putting robots into military situations will speed up things. I say it's also possible it slows things down because it doesn't matter if a robot takes a few hits. It does matter if one of our soldiers takes hits. On accidents, automation, I think that's no different from anything else. We regulate how trains are made, we regulate how buses are made, we have regulations. I think that's important, and we will continue to do so. And that's got to be part of the process. So I don't see any conflict with our standard practices there.
I think we're at the end of our time, but I think that was a really good way at looking at the potential hopeful recreation of industrial society in industrialization 3.0 via all these technologies leading to this world of creativity that has certainly not been the case for the past 20 or 30 years. So thank you.
Thanks very much.